Oh, that's funny. Really. Whoa. Ah, cool. Thanks. OK. Hi. Je vais probablement faire la présentation. Je vais faire la présentation en anglais parce que quand je parle de bits and bytes, j'ai plus de facilité en anglais que je m'excuse pour le public francophone. Oh, hi. My name is Jean-Loup Dupont. I'm here to talk about message switching for actor-based designs. So just 2 seconds about me. So I look after a small company that we do fiber optics test equipment. And inside the company, we've got some people. Well, the people use Python for their build systems, but also we have some web services associated with the product that are based on App Engine with Python. So I've been doing some Python since about 2007. And well, that's about it for me. So tonight I'm going to talk about what I call an M switch. It's an implementation in Python of a message switch, which is really rudimentary way of basically passing messages between actors. Okay, so I'm not going to talk about really the actor design pattern. Would be an interesting topic in itself, but that's not the main focus of this presentation. Okay? So why do we want a message switch? Because it facilitates the actor design pattern, but the way I've implemented it, the architecture I've used, makes it so that it requires less boilerplate code to wire stuff together, because actually if you've used message buses in the past, you might have encountered a similar pattern as to, you instantiate an actor, after all the actors, afterwards you instantiate the bus, you wire the actors to the switch, and afterwards you also need to explicitly say which message types each actor is interested in. So there's lots of boilerplate code. So I've came up some years ago, because I forgot to say that I'm a big fan of Erlang. So so in Erlang, doing message switching and actor-based designs is much easier. So I've taken some of the concepts in Erlang and applied it in Python, because Python is a great language, a great general-purpose language. So some attributes of what I call an M switch. All the senders are anonymous. There's no like actor XYZ or actor with address A1 or whatever. There's no need for addressing actors. The receivers, actually each actor is sort of comprised of 2 parts. So there's the receiver part and the transmitter part. Of course, you could have some actors that only send stuff, like a clock, for example, and some actors which only receive stuff, like a debug process or whatever. And the implementation I use can either be inter-process or intra-process. I very often use intra-process architecture, because I do lots of small programs, so some small applications. So I very often just use that architecture inside a process. So how does it all work? So each actor connects to the M switch. I'm going to show you some code and an API, an high-level API of what typically I use. And the first time a message of type X is sent, all the actors receive it. So it acts like a bus, a broadcast. And each actor afterwards, and that's let's say, not the novel part, I won't stretch it that far, but let's say the way I like to implement it is each actor interested in a message of type X replies to the M switch. I'm interested in that sort of message. So every time that message comes up on the switch, it receives it. And if it's not interested, it won't be bothered again. So the first time a message is sent, everybody receives it, but that's the only time. Okay. Yeah. So an high-level API would look like, because that can be implemented in any language. I've done implementation in JavaScript, in Erlang, in PHP, you know, a bunch of different languages. But Python is really cool for implementing this stuff. So the high-level API is you've got, you know, a connect sort of procedure. So each actor connects to the M switch, or subscribes to the M switch. The sending part is really easy. And the receiving part, well, it's upon subscribing, you basically have pass an actor, which can be a class or whatever, and it has an internal mailbox. And afterwards, when the M switch dispatches a message, it just sends it to the mailbox. So that's an high-level API, and some graphics to show the overall concept. Okay, so sending on the first message, everybody receives it. Everybody receives a message of type X, and afterwards, the actors which are interested in the message would reply back to the M switch saying, well, I'm interested in message X, or I'm not interested in message X, of type X, I should say. So instead of going in your code and saying, well, I'm interested in X, Y, Z, all those messages up front, you basically say, well, the first time I receive a message of type X, I'm either interested or not. So just a quick example on the sort of stuff I do with that sort of architecture. Let's say I've got a bunch of actors, like a presenter, which could be responsible of just outputting stuff to a user, a cache, a fetcher that goes out on the web to fetch stuff, to fetch data, a manager, and a stats engine. So let's say that the manager says, well, where's my data? And it goes out on the M switch, everybody receives it. This guy just snoops all the messages and does some stats, whatever statistics. Afterwards, the cache engine receives that message. Okay, if you remember, it receives the data question mark, and this guy replies, well, I don't have the data, and this guy sees that there's no data, local data. It goes out and fetches the data from whatever source, and everybody, well, receives that message. So now the fetcher comes back with actual data, so it's not none, it's actual data. This guy populates his cache, this guy snoops, and these other guys actually present and manage the data. So it's just a high-level example. So some code. This is just a tidbit. That's not the whole code, but it's just a tidbit of the M switch module. So as you can see, in this particular implementation, I used two message queues, one high priority and one of lower priority, because you don't want to get into a situation where you've got some blocking in your system. There's always some messages that need to be higher priority, so you don't want to get blocked in your application. So in this implementation, I just use the double underscores to say, well, if a message type starts with double underscore, it's of higher priority. So let's say, for example, a quit message. So a quit, you know, if the user wants the application to quit, no use doing other stuff, okay? Or at least do some cleanup and, you know, quit as soon as possible. And the subscribe is actually just a special message that is sent to the fabric to basically wire the fabric. Okay. so that's an example of a base class I use for the actors. I use threading a lot because I just can't write procedural code. I need to write asynchronous code. I just don't like procedural code. So everything I do is well, it's all message based and asynchronous. So it's just the way I do stuff. So you would have the base of an actor. You would have a message loop which processes the queues. Yeah, I use the Python queues. They're from the queue module. Okay, so because these guys are real interesting. They're thread safe, and it enables me to implement the message switching quite easily this way. So each actor, the base class of the actor, would have a message loop, and this function would dispatch the message to the actor, which I'm going to show you an example. So the way I use the base class is in the base class, when the DQ process or the dispatcher receives a message, it looks up the well, it based on the type of the message, it dispatches to handlers. So, for example, handler for question data. So you write your handler for the for that message type, and if it's for the message data, handler data, and you receive the message and you do your processing. And at the bottom of the code, you just instantiate the actor and just start it. That's it. So I was quite fast. I think so I've got a bunch of open source projects based on that technique. So you can very happy to let it in the open. So you just have to check it out. So I've got a bunch of time for questions. Maybe I've been a bit too fast. Wait.
Do you ever get bitten by using threading and the guild?
Well, most of the stuff I do is well, it's asynchronous. I use, like I was trying to say, is that I always think asynchronous, and I come from an Erlang sort of baggage. And so for me, sharing data is, I don't do that. So I don't get bitten by the Jill.
But, I mean, if you have one process,
yes.
You won't have to.
I have got a bunch of different threads. I've got like one of my projects. I think I had like 12 or something.
Right, but they'll never run at the same time.
No, I know. It's just the way. It's not time critical. It's not like I'm building something that's really time critical. Okay. The thing that can happen with that sort of architecture is that if you don't implement it with multiple queues, you're going to have a bunch of blocking. So you don't want to do that. That's why I've always put 2 queues. And the way that the dispatch loop works, oops, sorry, in the process queues, is that I always assign more quanta to the higher priority queue, and I sort of process a bunch of lower priority messages in a bunch. And of course, you don't want a message to take like 10 minutes to. Okay. Wait.
I've implemented something like this, and I'm really anxious to see your implementation. But
yeah.
The problem that I've encountered is that when you have many actors and then many messages being exchanged, it's really hard to debug an application like this. I've tried to trace it, and the file becomes big. I've tried to graph it, and I think like with graph is, and I think my eyes start to bleed. So I'm wondering, how can we enable people to debug a message-based system like this?
Yeah, well, a couple of different things. Normally, I do the architecture, the messages up front. I never start coding before I do all the messages, and I do some flows. of what's going to happen in the system, and afterwards I code. So, but of course, there's always some bugs. And the way I use it, the way I debug is I've implemented a snooping procedure. So you can say an actor receives all the messages, and I've got lots of debug info that it spits out. Okay, and one of those is, for example, the list of actors and the interest of each actor for a message type. So I've got this table that's being dumped as for example, a CSV, and I import it into a Google Docs spreadsheet. And normally what I do is when I plan the architecture, when I plan the application, I open myself up a Google spreadsheet, and I put down all the message types and all the actors, and I do some simple mapping. This guy is never going to be interested in this sort of message, and normally the message flow, for example, for a new user of the application, you would get, for example, message type 1 from this actor initiates the creation of a new user, for example, for the system, and you would say a sequence like 1, 2, 3. So I do that in spreadsheets and CSV dumps and stuff like that.
I think that experience is very valuable. If you could blog about it, that'd be wonderful.
Yeah. Yeah. It's. I love doing software this way, and you just can't do it any other way. I mean, procedures and objects, and I don't get it. Erlang is really cool in that respect. Yes.
For example, you have a cache, and you're sending a request for data, and the cache has it, and then your web server is also trying to get that data.
No. In that case, there's a bunch of different ways to deal about this. You can say that the cache, for example, always responds, even if it doesn't have the data. It says data, none, or data. So the other guy, like the fetcher would at least wait for a response on the bus that says data. So if it's none, I go and fetch it. Okay, a bunch of different ways, but it's pretty valid question. You've got, all my messages have no sender and no receiver. It's like you've got a bunch of actors. They know their job. You know, it's like you're in a company. You're hired by your employer. You know what you have to do. Okay, so when there's a new job that comes around, you just say, well, here's some data, and each actor knows what it has to do. Yeah, it's a very interesting topic. Design by actor, it's really cool, but it would require an entirely different presentation. Wait.
You said it was also part of the process. How do you do the process communication?
Well, in Erlang, it's sort of, when I did that in Erlang, it's sort of like given. In Python, I did it, and it used the TCP sockets. Use sockets. Well, like I say, I've also used AMQP some time ago, but sort of it was a bit heavy. I've looked into 0MQ, which is pretty cool. I think that's it.
Thank you very much.